Welcome to our OAuth 2 introduction. Let's go over the basics of OAuth 2, including the roles involved, how it works, and what benefits it can provide. Let's consider the case of John, who is a developer writing a personal finance application, MyBucks. He's been told by his boss that he needs to use OAuth 2 to authorize users of his application by using a bank's external authorization server. John's application will delegate the responsibilities of user authorization to some other service rather than managing them on its own. First, let's take a look at the high-level roles that exist within an OAuth 2 framework. For simplicity, we will use 3 roles to start. We have the user, the application, and the API. Within the API, there is an authentication server and a resource server, but we will cover the difference between those two later. With the growing popularity of OAuth 2, you've almost certainly seen these roles at play before in your everyday internet use. For instance, when you launch Spotify to listen to your music, you may have chosen the option to log in with Facebook, and Spotify requests access to your basic information and profile picture. Spotify is the application in this example, and Facebook is the API. Now, for John's case, it is his MyBucks application instead of Spotify, and instead of Facebook, he intends to use the APIs of various banks. So John's thinking, I get it now. When I log into Spotify with my Facebook account, Spotify grabs my username and password from Facebook. It's so easy. Wrong. This is one of the biggest misconceptions about OAuth 2 frameworks. Passwords are never passed around during this process. So how does it actually look? Let's use John's personal finance application, MyBucks, as an example. Sarah is a user who wants to manage her finances using the dashboard views that MyBucks provides. So she opens up MyBucks and wants to connect her Memorial Bank checking account in order to view her balances and transaction history in MyBucks dashboards. When Sarah clicks to connect her Memorial Bank account, MyBucks will make a request to the Memorial Bank authorization server, which will display to Sarah a Memorial Bank authorization screen asking her to authorize MyBucks to access her bank account. You may recognize these types of screens from other use cases, where a prompt will tell you what permissions an application is requesting. In our Spotify example earlier, Facebook's authorization screen asked you to authorize Spotify to access your Facebook account information and profile picture. Sarah grants permission to MyBucks to access her account balances and transaction history via the Memorial Bank authorization screen that she was shown. That authorization is sent back to MyBucks by Memorial Bank, along with an authorization code that MyBucks will use when requesting an access token to see Sarah's account. Now is where, technically, we come to the distinction in the API, or Memorial Bank, between the authorization server and the resource server. MyBucks is going to take Sarah's authorization grant, including the authorization code that I mentioned, and use it to request an access token from the authorization server at Memorial Bank. Note that none of Sarah's protected resources, her account balances or information, are located on the authorization server. This server is only responsible for authorizing Sarah as a user and providing the proper access token that will eventually allow MyBucks to retrieve her protected info from the resource server. After accepting the authorization grant and code that MyBucks provided on behalf of Sarah, Memorial Bank's authorization server provides MyBucks with an access token specifically for Sarah. This token will be included in a request from MyBucks to the resource server, and it provides MyBucks with access to only the 2 things that Sarah granted it permission to see: her account balances and her transaction history. MyBucks sends the request to the Memorial Bank resource server with this access token included, and Memorial Bank identifies that this token is valid to access those particular pieces of Sarah's account. The resource server sends the protected resources that were requested back to MyBucks, and the application now has Sarah's balances and transaction history to display in dashboards and metrics for Sarah. Note that throughout this workflow, OAuth 2 serves as the authorization framework. The actual authentication of Sarah as a user occurs with OpenID Connect through the use of ID tokens that are passed along with the access tokens shown here. In order for all of this to work, though, John needed to register his MyBucks application with the Memorial Bank API service. Independent of any user involvement, John needs to provide the API with MyBucks' name, website, and the URL to which the Memorial Bank authorization screen will redirect the user after they have authorized access to their account. Once MyBucks provides that necessary information to the Memorial Bank API, the API will send back a set of credentials to MyBucks. These credentials include a client ID, which is a public and unique identifier that will be used to identify MyBucks as an application, and a client secret, which is a private identifier kept secret between the app and the API that is used to authenticate MyBucks when it makes a request for an access token. Let's revisit the actual workflow for a moment. Remember that the first few steps in the process are essentially getting Sarah's permission to access the protected resources in her account. In OAuth 2, there are 4 different grant types for different use cases. The grant type that we use in our example is the authorization code grant type, which is how Sarah granted access for MyBucks to see her Memorial Bank account information. This grant type is used for applications running on web servers. There are 3 additional grant types that we won't detail in this video: implicit grants, password grants, and client credentials grants. Once everything is implemented, we have happy and informed parties all around. Sarah gets to log in once to access all of her account balances across different bank accounts. And John's boss is thrilled because MyBucks supports easy and simple integration with various banks through OAuth 2, and it simplifies the customer experience for Sarah. All of the OAuth 2 capabilities that we've described at a high level in this video are available with InterSystems Cache, which can serve in any or all of the roles shown in this overview. Visit learning.intersystems.com to learn more about InterSystems products and technologies.